All right, hello everyone. Sorry about that, having some technological issues that seem to be fixed, but I didn't really do anything to fix them. So yeah, not sure if you've ever had like code like that before, where it like doesn't run and then all of a sudden like it just decides to run and you're not sure what happened, or it's a little disconcerting because you don't know when it's going to happen again, but for now everything seems fine. So anyway, we were just had a little bit more on this video just about interpreting this slope coefficient and why this um, slope that we raised by e matches with our odds ratios from before, from increasing x by just 1 unit each time. And so let's delve into why that is. We could figure this out just from algebra. And so let's calculate just for a general x. Let's calculate estimated odds. I'm just going to say when x is x, but don't let that confuse you at all. Just for like a general x, it could be anything. Then our odds are going to be just from that earlier equation, that. And so then I'm just going to rearrange this a little bit, and we could remember our like power of exponents rule. I'm not sure if that's the name of this rule, but whatever the rule is called, where this is actually equal to that, because when you have the same exponent base, then you can add up these together and whatever that rule is called. So that's going to be equal to that. And now let's do the same thing for x plus 1. So we're increasing our explanatory variable by 1, and let's find what that estimated odds is going to be. And so now I'm throwing in an x plus 1 here. Using that same exact rule, and then just distributing the beta hat 1 in here. We wind up with this. And so from here we could see that, okay, if we increase x by 1, it looks like the odds is changing by a multiplicative factor of this e to the beta hat 1. And so that's why this e to the beta hat 1 matches this odds ratio from before. Okay, so to make that even more clear, it's like 15 is the x plus 1, 14 is the x, and so then that odds ratio is going to be, this might be like overkill, but just in case, then that odds ratio is going to be this. This all cancels, and so our odds ratio is just e to the beta hat 1. So that's why that all works out. Okay, and so therefore when we go to interpret our beta hat 1, I'm going to do it for this problem first. And so it'd be something like, okay, well, 1 student increase in the student to faculty ratio is associated with a 1.7814 fold. So this fold word means that it's multiplicative. And so, or you could say like a multiplicative change of 1.784, a change in the estimated odds that a college is public. Because remember, public was the one that got the 1, and private had the 0. All right, so in general, I'm kind of running out of room, so I'm going to come on down here and say, so something more general might be, okay, a 1 unit increase in x is associated with an e raised to the beta hat 1, whatever that turns out to be, fold change in the odds that y is the 1 category. All right, so that's more of a general interpretation. If this doesn't feel like as satisfying as our other interpretation, that's totally fine. And by our other interpretation, I mean the one that we had for multiple regression. This interpretation in terms of the odds is a little bit strange, and we're going to get into that a little bit in the next video that's going to talk about these notes about odds interpretations and why they're not exactly intuitive to most people, at least. So yeah, after this, you should be able to get started on the day 21-22 handout. And as always, let me know if you have any questions about anything.